What do you mean by regenerative medicine? Regenerative medicine is a branch of research that aims to engineer, reestablish, replace, or even regenerate a body, cell, organ, or tissue to restore or establish a normal function. It's quite complicated, so let me simplify it more. I will give you a couple of examples. The first one is liver cirrhosis. Liver cirrhosis is a major health problem all over the world. Unfortunately, any medical intervention ends up unsuccessful, making the only hope represented by organ transplantation. And believe me, the organ transplantation waiting list is a pretty long one. So a need has been risen for another alternative therapeutic protocol. Here, the role of regenerative medicine acts as a magical wand that aims to reverse the process of fibrosis. In liver cirrhosis, the normal hepatocyte is replaced by a fibrous and functional tissue. So we need to replace or regenerate the fibrous tissue and converting it into a healthy hepatocyte. And that's achieved quite well by many researchers performed in the field of liver cirrhosis regeneration. Another good example is bioprinted kidney. What's the bioprinting? Okay, any printing process needs two main factors, the paper and the ink. In bioprinting, we use something called scaffold as paper and we use cells as ink. The scaffold either natural by removing the cells of an organ, leaving only the extracellular matrix, acted as a skeleton over which the cells grow, its biological scaffold, or synthetic three-dimensional scaffold based on scanning using 3D MRI. In case of kidney, Anthony Attalla is the best researcher in this area. You will find a link below that you can search and listen an amazing, inspiring lecture Anthony Attalla giving about bioprinting of the kidney. These photos represent that kidney harvested, decellularized, and then recellularized by a patient's own cells, stem cells harvested from the patient's bone marrow. Bioprinting is a kind of tissue engineering. Another example is bone defects regeneration. Bone defects that beyond the body ability to heal, requiring an intervention to be able to fix this defect. Okay, the defect is filled by either scaffold or cells or even injecting growth factor or combination of three, scaffold, cells and growth factors, to fill the defect and aid the body to rebuild a new bone regeneration. Many other examples are valid in clinical and research bases, represented by skin regeneration, cartilage regeneration, neuro regeneration, heart and heart valves, blood vessels, windpipe, tendons, and any tissue you can imagine, even hair, tooth. Yes, I am serious, but how? To say that you are working under a regenerative medicine area, you have to use one of these three things. Either you are using growth factors, it's a very simple, primitive thing that stimulate the body cells to grow faster. The most common example of growth factors that used in clinical and research bases is the platelet-rich plasma. Another thing is stem cells. It's a huge research area which come from many sources, either in embryonic stem cells or in adult body, from adipose tissue, bone marrow, peripapillary glands, and other possible sources. The third thing you can use, and you are working under the area of regenerative medicine, is scaffold, either synthetic three-dimensional scaffold, which must be reabsorbable and capable of holding cells, or biological scaffolds by taking an organ or body tissue from a cadaver, then decellularize it, use it as a scaffold over which you can build or pipeline cells, seeding cells over scaffolds. In addition to a lot of lab equipment, bioreactors and others to be able to perform this work in the best way. You will find topics under the area of regenerative medicine, special focus on surgical affection on the Surgery Day Faculty of Veterinary Medicine that will hold on March the 7th, 2016. I'm waiting for you to see you.